Hello, so my name's Nicholas, and this is Dr. Simon Davy, and this is a semi-serious, semi-fun brain break sort of a talk that we're going to give entitled Trouble at t'LeedsDataMill. Oompah.py meets big brass meets big data, okay? And it's basically an exercise in oralizing data, telling stories with data. So this is the agenda for the talk. So both Simon and I are going to tell you Oompah.what. We're going to give you an overview of some data analysis we've been doing, some musical mischief, that's me and my tuba. Then we're going to have some questions from you, so we're doing things a little bit the wrong way around. At the end, we're going to have a performance. It says performance. I'm going to press the play button on a recording that I've done. We've not really got NDB Brass Band hidden away somewhere. I'm not going to suddenly march in and play something, I'm afraid. Sorry about that. But we have got a recording of them, okay, and we'll end our talk with that. So we'll start So Simon lives in Leeds, and I'm friends with Mark Barrett, who runs t'LeedsDataMill. t'LeedsDataMill is a sort of civic hacking type organisation where they're taking data, open data, about the city of Leeds, and they're doing interesting things with it. And their tagline is that we tell stories with data, okay? And they ran a hack day in May, something like that. Yeah, in May. And so I went up there and I met Simon there, and we got up to all sorts of interesting mischief. So we asked ourselves, can we tell an engaging story about Leeds with the data that we found at the t'LeedsDataMill hack day? So this is what we found.
Yeah, so I've been looking before the hack day on what data sets were available. There was all sorts of stuff. Yorkshire Water had released all kind of information about their water network system and all kinds of really interesting stuff. But the thing that struck my mind was the city centre footfall data, which is there are cameras in 8 locations in Leeds city centre, as you can see on the map here, and they count the number of people who walk past every minute to give an idea of how the city centre is developing, moving, traffic is declining, that sort of thing. It's all sort of analysing the city, but they released this data. So the first idea was, well, I wonder if we could actually represent this musically. Naturally, the idea of footfall struck me as something we could do, like make the sound of the city, or so on and so forth. And it sounded like a really fun way of doing something fun. A lot of people were doing very serious projects of, improving tourism and visitor information, and we just wanted to do something a bit different. So I suggested it to Nick.
Okay, so something you should know is that Simon is a percussionist, which is why he's stomping around like this. Okay, he likes hitting things. He's the hit squad. I used to be a professional musician. I trained at the Royal College of Music. I'm a tuba player. So crazy idea number 2. We asked ourselves, I thought this was brilliant, awesome. We can do something musical and a little bit silly, because I wanted to have a bit of fun. And fun. Fun is the big thing about this, okay? So we asked ourselves, what musical genre epitomises Leeds? Up north, flat caps, whippets, etc. And we thought, brass band. That's sort of like, I don't know, Victorian serial killers. With tubas, they'll knock you off with a euphonium or something like that. Very frightening photograph, especially the guy in the middle. Christ. Very small, yes. So our aim in the day was to, I'm just going to read this out, is to write Python scripts that turned the raw footfall data that we had available to us into music for brass band called Rhythm of the City, okay? And so Oompah.py was ironically checked into GitHub. And there we are working on it during the hack day. I was told this, Mark, the organizer, said, look like you're being inspired. So I was I'm trying to be inspired there. Yeah. So we got the data, and then we did some data munging.
Yes, not so much analysis, but munging. The data we got looked a bit like this. This is an example. So you can see Monday, 0 is midnight, so you can see on Monday, on this particular date, there was 59 people walked through this particular camera area at, the location is Albion Street, at that time, and you can see it gets busier during the day and goes away, but it's aggregated per hour. So there's not a lot of information. They actually collect it per minute level, but they haven't released that data. So first off, the idea of there's not a lot of numbers here to do a lot of generation with. So that was a bit of a problem. So we got the data and we cleaned it up a bit, and what we ended up doing was a bit of time travel. Oh, we did some analysis of the data first, sorry. So this is just a quick dump of all Tuesdays ever in the data, about 5 years of data, and a histogram to see. So you can see a pattern in the day. It's quieter in the small hours of the morning, it gets busier at rush hour, between 6 and 7. It dies down a bit in the morning, gets busier again at lunchtime, dies down a bit in the afternoon, and then everyone goes home, and then there's a bit of nightlife. Keeps it more spread out in the evening. So we had a look at the data, and that's what you would intuitively assume from the data, but the data was there, it showed it. And so we thought, well, hang on, we haven't got enough, like we can't just pick a random day and make music. We haven't got enough data, haven't got enough numbers to do anything interesting with that. So we ended up smooshing them all together into one big list of data for we actually split them into weekdays and weekends. The original idea was to have a musical piece of 2 movements. The weekday, the working week, and the weekend. We ended up doing brass band for the week, for the work day, the working week, which kind of fits going to work, and all that. And I thought about doing some filthy, dirty dubstep for the nightlife weekend, but we never quite got that far. So what we ended up doing was compressing all of the data for all work days, for a particular hour, for a particular location, into a massive big list of all those numbers. Then we can do something with it. So if you like, we're smooshing that data all together. So if you're generating something from this, you're effectively generating from the data over the past 5 years, all kind of smooshed together. So give us enough data, enough randomness to do something with. There we go. So then we generate some musical things from this data. So pitch, Nicholas is going to talk a bit more about this later, and scale, but essentially we choose a scale and we choose a random note from that scale using the data as we walk along the data. So it starts off 5 years ago, and as you go through the data, it ends up sort of this year towards the end of the pitches you're generating. We also did some rhythm duration. One of the things we did here was for a particular hour and a particular location, we measured how busy it was relative to the rest of the world and the data, and described it, bucketed it into an intensity level, and used that to choose some rhythm patterns, which Nicholas is going to talk about a bit more later. And then we combine the 2 of those into a voice by merging pitch and data. So the length equals 8 at the top there. We're producing by default 8 bars of music in 4/4, and we generate the random. We use the data to generate the pitch, the data to generate the rhythm, chosen from some predetermined patterns, and that produces the data that we're using. So, Nicholas.
Right, so we have some data that we can play around with, and we need to represent this with music, and this is what I was involved in. So, bit of history. I've been to so many talks as a musician and somebody who's a programmer, and people will say, hey, we're doing computers and music, and it's very easy to make bloops that sound like this. Now that's about 10 seconds of me pushing stuff through MIDI, really, and it's not particularly nice to listen to. That's only 10 seconds, and I find that intensely annoying. And to be honest with you, it sounds like a chimpanzee on the keyboard. That isn't a particularly useful way to make a piece of music, no matter what you say. So we're going to go a bit philosophical here. So Charles Edward Ives was a renegade American composer, one of my favourite composers. I wrote my dissertation on him when I was doing my BMUS, and he has a famous quote, "Oh my God, what has sound got to do with music?" And the point he's trying to make here is that, you know, sound is just the medium through which music is expressed. Music is the sort of the feeling or the narrative or the structure that you hear as a result of hearing these sounds. Okay, and so music affects us because of the effects of the sound, and music engages us to listen. Okay, because there's some sort of a story being told. Music isn't just a series of bleeps and bloops like I just played for you. It might start soft, and then it might increase, and then in intensity, and then go soft again. So you intuitively hear this, or there's structure in the music. So there's verse, chorus, verse, chorus. Oh, it's the chorus again, I'm going to join in. And you understand intuitively as a human being that this is how you sort of listen to music. And so what I'm trying to say is that music, in some sort of a sense, tells a story in sound. And what we need to try and do, there's some sort of discernible narrative. And so what we need to try and do is, can we reveal the story that's hidden in the data in a way that tells a story with music rather than just generating bleeps and bloops and so on and so forth. So we asked ourselves this question: can we reveal the story through music? And so in order to do that, we need to map the dimensions in the data onto elements of music so that it makes some sort of a sense in a musical way. So I'm just going to go through some of these elements. Music is a highly dimensional sort of space, as it were. So these are the ones that we're particularly interested in to make this piece of music come alive. So as Simon has said, he generated pitch. So pitch means how high or low. High, low, a note sounds, okay? It's the frequency. And rhythm is simply a sequence of different durations of pitches, okay, played through time. And when you have pitch and rhythm added together, you get melody, okay, which is in effect what that third function was that you saw. That's what that did. Timbre is the quality of the sound. So if I were to play the violin, you'd probably all laugh at me. But if I played a C on a violin and then played a C on a flute, the quality of the sound would be different. You'd say one sounded like a flute and one sounded like a violin. That element of music, that's the timbre, the quality of the sound, okay? And dynamics is how loud or soft the music is. It's the volume to the layman. Now, key. Key in music is the set of available pitches that you use when you play a piece of music. So the key of C major has 7 different notes: C, D, E, F, G, A, B, and C. Okay, well that's 8, but that's an octave. Anyway, don't worry about that. It's just the set of notes that you are allowed to use while you're playing this piece of music. And harmony, if melody is how pitches move through time, harmony is how pitches sit on top of each other at one particular snapshot in time. Okay, so if melody is the horizontal sort of movement through time, harmony is the sort of vertical axis. Okay, so how do they fit together? Texture is how the harmonies is voiced. So if we have lots of notes that are very close together, it sounds quite mushy, the music, whereas if we space the parts apart, if we space the harmony apart, voiced quite sparsely, you would intuitively say, well, this is a sparse sounding piece of music. It sounds empty, okay? Again, we sort of start, we have elements that we can use to tell a story here, etc., etc., etc. Lots of different elements of music that we can use, but these are the ones that we're particularly interested in.
As a drummer, I have to notice that he misses off tempo, the speed of the music, which is a typical brass player attitude.
Yeah, I like to answer that. Okay, we don't need to put tempo in because, as everybody knows, drummers start steady and then just get faster and faster and faster. So you just ignore tempo, which is what drummers do. So, given this sort of data, this footfall data that we know about and we've munged up a bit, and these musical elements, and we want to tell a narrative in the music, not just make random bleeps and bloops, how do we go about constructing a piece of music? So, this is the sort of the modus operandi. And what I did is I took the raw data and I turned it into LilyPond files, okay? And if you don't know what LilyPond is, it's a musical typesetting program, part of the GNU project, so it's open source, it's free software, okay? So the Python script output a LilyPond file. I got LilyPond to parse that, and that produced a PDF of the score and a MIDI file that made me cry. Each instrumental group in the band represents a specific area of the city. Therefore, cameras and locations are differentiated by timbre. So, for example, the railway station camera might be represented by the tubas in the band, whereas the town hall camera might be represented by the tenor horns, okay, and the theatre district might be represented by the cornets, and so on and so forth. So you'll be able to hear different parts of the cities waking up as different different parts of the band wake up in the piece of music. That's what we were trying to get to. And now the amount of footfall in a particular location changes the intensity of the dynamics, how loud or soft it is, and the rhythm. So that gives the impression of the more footfall there is in a location, the louder or the busier the melody will be. Okay? And we don't want bleeps that are difficult to listen to. So what I've done is used something called a pentatonic scale. As the name suggests, it only has 5 notes in it. And the way you choose those notes means that they will more or less sound nice when you play them together as a harmony. Okay, so it shouldn't be squeaky gate music that we're producing here. Okay, now the key changes. We modulate, so we change pentatonic scales. And the way, some of you will know about the circle of fifths, which is how keys relate to each other. So what I did is use this with the pentatonic scales. So midnight and midday are as far away from each other in this circle of fifths as possible. And what happens is that the piece of music modulates through the day to a foreign key, and then comes all the way back. So you can tell from the sort of the key structure where you are in the day as well. Each hour of the day is only represented by an 8-bar fragment. So every 8 bars we get a new hour, as it were. And just because we want to give you a clue, at the beginning of each 8 bars, we get the tubular bell part to go dong, 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 to sound out the hour that the next 8 bars are going to be about. So you've kind of got some sort of geography in terms of sense of time through the day with the progression in the piece of music. Okay? So, the result. The Rhythm of the City, a musical representation of the footfall data through the medium of brass band, composed by the people of Leeds. What you might notice, here's the tubular bell part here, and we start at midnight, and it goes bong, 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 12 bongs like Big Ben, okay? So I have this piece of music. What I ask myself, and I'm sure you'd be intrigued to know, is does it work? So it's tuba time. I'll talk a bit and then... okay. So one of the interesting aspects of this is that a computer can just produce pitches, and it has no physical sort of consequence as a result of that. I have to tell you, from years of experience playing the tuba, it's a very physical thing to do. Okay, you're breathing, you're pushing lots of air through the instrument for a start, and you don't just blow into a tuba, you buzz your lips as well. So all the muscles on my face, it's like sort of, I don't know, Olympic gurning, really. It's just you use your lips an awful lot. It means we're good kissers there. So what I'm going to do, that's what I tell my wife anyway. You have to tell her? Yeah, quite well, there you go, there's the proof. So I'm going to play you the tuba part for 1 a.m., 7 a.m. and 12 noon. So you will get kind of the middle of the night when it's really quiet and there's not a lot happening. 7 a.m. the city's starting to wake up, and then at noon everybody's around trying to find their sandwiches, and it's really quite busy. And you'll be able to see the differentiation, I hope, in the melody that's produced. And then, okay, I just better get on with it, haven't I? So, obviously, this is a tuba. I blow in here, and the sound comes out here. Is there a mobile version of this, please? This is the pocket edition as well. By moving the valves, I change the length of the tube, change the pitches. That's essentially how a tuba works. So, I've not warmed up like any physical activity. I'm being shouted at by or gesticulated at by the guy from Audio Viz. The last time I did this at PyConUK, his head nearly exploded because he was wearing headphones. Are we all right now to play?
What's in the camera?
You want to see the audience? You'd rather see their reaction. Okay, I've not warmed up, so I'm just going to play a few notes, so I'm not warmed up still. so this is 1 o'clock, and there are lots of rests in this, and it's slow moving. So it starts like this. But that's all very sort of mating call of the humpback whale, so things start to move a bit more at 7 o'clock, okay? And it's a little bit harder. That was played piano, which is soft, lead and all that. That's a soft tuba. This is mezzo piano, medium quiet. So that's 7 o'clock. There's not so many rests, the music's moving about a bit. Okay, so this is loud, this is midday, there's an awful lot of footfall happening, okay? And I've got to be really good at sight reading. Big day. Okay, so we've got about 5 minutes left, so we will answer your questions, I guess, very quickly, and then we will play the whole piece. When we play the piece, it lasts 10 minutes. You'll get a good sense of the piece of music by about 5 minutes in, so we don't mind if you leave because it's going to be lunch soon. Do we have any questions?
I said we played a scatio.
I still can't hear a word you said.
We were playing a scatio for 2 hours at the play.
Oh,
okay.
Thank you.
There's questions over here. Is someone going to run around with a microphone so that we can hear what people are asking?
It's on.
It's on.
Which camera is the tuba?
Number 7.
So,
no idea. I don't know.
we don't know where this
It's in the source code.
It's in the source code. Yeah. Check it out.
I can tell you afterwards. I don't know off the top of my head.
So how did you generate the melody, like the tune? Is that from the data, or did you pick a melody first?
Yeah, so it's all from the data. So we pick a scale at random by summing the last data, we walk through the data, summing it up as we go and modulating it by the size of the scale and choosing a number.
But you picked an algorithm that would make it tuneful?
We picked a scale that would make it tuneful. So we put some constraints on it, so it's not the random bloop noise that Nick played.
Okay.
Just a question about the random aspect of it. Did you kind of run it all a few times to see the different versions it generated?
I made it very, very careful steps to make sure it's deterministic. So we always got the same piece of music unless we changed the way we were generating the music. So there's no randomness in it at all. It's all from the order in which the data is historically in the data set. So otherwise, we would get a different piece every time. So in order to gauge our changes and improvements, whether it sounded better, we wanted the same data flowing in.
We've got one last question to that.
When's the album out?
We have joked about the dubstep idea could work for next year, like the weekend movement. Drum and bass. We can do a drum and bass thing for next year, maybe.
Okay. So, the moment you've all been waiting for. So, obviously, having been a musician, I know lots of musicians, and trombonist I play with regularly, he's also in a brass band called the Enderby Band, and they are the Midland Area Regional Brass Band Champions, first section, 2014. So, in case you don't know anything about brass bands, it works a bit like football, I kid you not. There are leagues, and the championship section is like the Premier League, first section is like the first division, and so on and so forth. And you have player transfers and this, that, and the other. And there are contests as well. And contests are like, you know, where you work out where you sit in the league, and the ones at the top of the league, they get promoted, and the others get demoted. Anyway, you get the idea.
What's your current transfer price?
Yeah, they pay me to leave. That's the thing. Okay, so let's see if this works. Like I said, about 5 minutes in, you'll get the idea. Okay. that's going on in the background. This could be sort of some sort of form of torture because you're so polite sitting there. It's this damn brass band piece that's got another 5 minutes to go, and it's dinner time. So if you would like to leave, please, we won't be offended. Sorry? Yes, it is. There's sources in GitHub. So, yeah. That's it. That's the end.